Okay, so we want to be able to now use these reciprocal identities to evaluate the trigonometric functions. So let's say we have an example where we have cosecant of theta equal to 7/4, okay? And we want to know what is sine theta. Well, using the identities, we know that cosecant of theta is just 1 over sine theta, or their reciprocals. So sine theta equals 1 over 7/4, which equals 4/7 in this case, right? So reciprocal means that the numerator and the denominator of the fraction flips. So when we're given something in fraction form, essentially to do 1 over it, the numerator and the denominator reverse, or they divide. Okay. So now let's do one a little bit more difficult. So if we have cotangent of x equal to 2 over 5 square root 5, and we know that sine of x is equal to square root 5 over 3, we want to find cosine of x. Well, what is cosine? Well, we know that cosine and sine and cotangent are all related using our quotient identity. So we know that cotangent of x is equal to cosine over sine. Okay, which means we know that 2 over 5 square root of 5 is equal to cosine x over square root 5 over 3. Well, to do this, we're going to now just multiply by the square root of 5 over 3 on both sides. That cancels. Square root 5s cancel. And then you just multiply across, and we get 2/15 equals cosine of x. So we're using our identities to evaluate another trigonometric function. All right, let's do one more. All right, so we know that secant of x is equal to 5/3. And we want to find cosine of x. Well, we have to think to ourselves, how are cosine and secant related? Are we going to use a reciprocal identity? Or are we going to use a quotient identity? Well, if you look back at the previous slide, we know that secant and cosine are reciprocals. So we're going to use the reciprocal identity. We know that secant of x is 1 over cosine of x. So we know that cosine of x is 1 over secant of x. So if secant is 5/3, cosine of x is just equal to 3/5 because they're reciprocals. All right. And now I bet you can bet that we're going to use, this one's going to be a little bit more challenging. So we have cosecant of x equal to 25 over 7. We have secant of x equal to 25 over 24. And we want to find tangent of x. All right, this one's a little bit more challenging because cosecant and sine are reciprocals, secant and cosine are reciprocals, they're not directly related to tangent. But we know the quotient, that tangent is equal to sine over cosine. So first we're going to use the reciprocal rule. Using that for cosecant, we now know that sine of x is equal to 7 over 25. And we know that cosine of x is equal to 24 over 25 because they're reciprocals of secant and cosecant. And now we just know that tangent is sine over cosine. So tangent is 7/25 all over 24/25. Okay, well now we just have to do a little bit of dividing fractions. So we have tangent of x equal to 7 over 25 all over 24/25. Well, when we're dividing fractions, it's really 7/25. We can multiply the flip of that, 25 over 24. The 25s cancel, and we're left with 7 over 24. Right, so our first two identities are the reciprocal identity and the quotient identities. These are what we've been using since the beginning of trigonometry, and we are just going to continue to use them to evaluate trig functions where we see fit.